This is Star Talk, and I'm your host, your personal astrophysicist, Neil deGrasse Tyson. I'm the director of the Hayden Planetarium in New York City, which is part of the American Museum of Natural History. And I got my co-host with me, Eugene Merman. Eugene.
Hello.
Dude. You know what this is? This is Cosmic Queries edition.
Yeah.
Cosmic Queries. And I'm ambivalent whether I prefer Cosmic Queries that is single topic or whether it's potpourri. Mm-hmm. This one is potpourri, which is easier to stump me. And if we're going to do a potpourri, I don't want to do it alone.
Okay.
But I know who to call.
Mm-hmm.
I've got like a bat signal, and my friend and colleague, Charles Liu. Charles.
Hi, Neil.
There you go.
Or shall I say Robin?
So this is not your first time on Star Talk. It's your nth time on Star Talk, as we say. That means you've lost count, and it's some large number algebraically. Mm-hmm. And so, Eugene, we have questions that come to us over our Facebook pages and our Twitter and other outlets, and sometimes we can gather them into one topic, but other times we can't. And this is the potpourri. And so I have not seen the questions. No. Eugene is going to read them, and you and I are going to try to answer them. That's what this is. And if we can't, we just say we have no clue. Go on to the next one.
Then I will answer it. If you don't know, I probably know it.
And Charles might, and I might not even agree on an answer. That would be kind of fun. We'll see.
That would be awesome.
Scientists ever disagree? Just kidding.
So let's do this. Okay.
All right.
What do you have, Eugene?
Well, this is from Patreon. A Patreon.
Oh, wait, by the way, just quick, our Patreon supporters are one of the categories of Patreon support gets your question asked first.
Yeah.
So I don't know what that's worth to you in supporting Star Talk, but that's what's going on there. And the reason why I have Charles is Charles knows so much about random stuff. Like spooky amounts of random stuff.
Mm-hmm.
Is that good or bad, Neil?
It's both.
We'll find out what you know, and then I'll let you know if it's good or bad.
All right, there you go. Eugene, you're the adjudicator. Go.
Okay. Kelia Silvis asks, and Jeremy Kaiser, together from Minnesota, they ask.
And they are Patreon supporters. Thank you for your support.
Thank you. Will asteroid mining ever be financially viable from a purely business standpoint?
Ooh, let me answer that, and then Chuck might have a additive to that. Mm-hmm. I did not believe that it could be financially lucrative, because if there's gold on an asteroid, mm-hmm. then you go get it. What did it cost you to get the gold? It probably more than the whatever $1,000 an ounce it's going for now. So what's the point? Until I spoke with asteroid mining people who said in the future we're going to have operations in space, manufacturing in space, on the moon, on Mars, at the gravitational balance points, the Lagrangian points, and they will need raw materials. And so you would go mine the asteroid, take the raw materials to these other places, and then you don't have to go in and out of Earth's atmosphere in our gravitational well. Is that about where you said on this, Charles?
I think so. So within, say, 30 or 40 years, it won't be feasible. But as soon as we get manufacturing in space, it will start becoming economically more feasible.
Is there an amount of platinum that an asteroid could have that would make sense to bring it back to Earth?
So I've thought about this, and let's say there is such an amount, and then you bring it back to the Earth. What does it do to the platinum market? It completely drops the price of platinum. Okay, so now watch. You say, well, that's bad, you might say. However, if the price of platinum drops, or anything that's previously cherished and in rare quantities, creative other things you can do with that material start to gurgle up on the landscape of innovation.
Right.
And not that I can think of one now, but Charles, what's an example when we finally aluminum, when it was first extracted from bauxite.
Yes.
It was a cherished metal. It was light. People were replacing silver with it.
Yeah.
It was, you wore aluminum because to show you were wealthy.
That's right.
And then once that process, it's not mining an asteroid, but it's the same idea. Once that process became more and more efficient and cheaper, and now we throw away aluminum.
We wrap our food in aluminum.
We wrap up an unthinkable thing back when they first extracted it from bauxite.
That's right.
So then,
I don't think it's necessarily a bad thing to completely collapse the market
Right.
of a metal that is previously rare.
So what if it was a metal that has not yet been discovered? That would be the only thing that might be valuable enough to bring back.
I think Charles, correct me if I'm wrong, the periodic table of elements is complete at this point.
Well, up to about 114 on the atomic number scale, yeah.
So what about 115? Is that not possible?
That has a half-life that's so short that it would disintegrate. It wouldn't survive in an asteroid. But what you might be getting at, Eugene, is the issue of having rare earths, little tiny percentages of things that we don't normally use a lot right now, but say we put in semiconductors to increase the ability of our cell phones to run microtransistors and things like that.
Yeah, because just because they're rare on Earth doesn't mean they're rare somewhere else, right?
Exactly.
They're rare earth, not rare asteroid.
Not rare asteroid.
So the answer is not a particularly great business model right now.
Yeah, except it could completely transform civilization in the utility of one element versus another.
Once you're in space, it's easier to get more gold in space.
Keep going.
Yeah. All right. So Megan Fischel, also a Patreon patron, asks, a few of my astrology-inclined friends claim the reason my iPhone has been a bit dodgy recently is that Mercury is in retrograde. Is there any validity to their claim?
Charles?
No.
Okay.
Sorry. Wow.
Let's say this. Mercury does go in retrograde. But when it does, we can't see it because it's actually in the direction of the sky that the sun is. So we wouldn't be able to detect it anyway in any visible format. And so in terms of what's happened to the cell phone or anything like that, any kind of effect is completely non-existent. Now, it's interesting that you say this, though, because I was getting on a bus once in New York's Port Authority about 10 years ago.
And the bus went retrograde.
Somebody barely got on the bus, was like dashing on and sat next to me and said, I know I was late because Mercury was in retrograde. I just knew it. So maybe, collective belief creates a fantasy that might be propagated to this day in modern cell phones. Who knows?
Yeah, too bad they didn't leave 15 minutes earlier.
And another point about the concept of retrograde, the very word retrograde traces from a time when we had no notion that Earth was in motion around the sun. And so people actually believed that Mercury would be in motion in space, slow down, stop, reverse itself, and then pick up its previous motion slightly after that, as though that was a physical thing happening to Mercury. And retrograde, all it is what is your point of view on objects that are all in harmonious orbit moving around the sun. And so I thought when you talked about the person almost missing their bus, I thought you would say when you're on a bus looking out the window, see another bus, and you see that bus go backwards, and half the time you see that, you say, you're actually going forwards.
Yeah.
Right? So you're going to say, oh, it's backward bus. No, you're the one in movement, not that. And so a lot of that language and a lot of that cultural misappropriation of cosmic phenomena came about because we did not know that we were all moving around the sun. It's that simple.
Okay.
Yeah. Okay. Next.
Ben Yeast from Facebook asks, I read that if our universe turns out to work a certain way, it's possible for black holes to rotate so rapidly they prevent an event horizon from forming. If we do live in a universe where these naked singularities are possible, what evidence of their existence would we look for?
Ooh, Charles, I got to.
Well,
that's a hard one. Charles, take it.
Thanks a lot. He might be referring to something called a maximally spinning Kerr black hole. And that is theoretically possible, although it wouldn't last as long as a typical black hole that's spinning at a slower speed, just because it wouldn't stay in equilibrium very long.
What's that length of time we're talking about, like milliseconds or years or hours?
Well, I have to go back and check my general relativity notes from graduate school. I'm sorry.
Me too.
Okay, you too. Charles, this is Cosmic Queries. You can say, I don't know. I once knew, I don't know anymore. I'll get back to you. Call me in the morning. So if we don't know, we'll just go on to the next question. That's part of how part of how we roll here.
No, that's fair. Okay. Now, naked singularities, though, if you're looking for them, you're kind of looking for them the same way as you look for any other black hole, through gravitational lensing. You want to see what they have done to the view of space and objects in space behind them. And by the patterns that they create, you can deduce whether they are maximally spinning or whether they're static or if they're supermassive or any combination thereof.
So once again, the power of inference, once we have good data on on what other things are doing in their vicinity.
Yes.
Yeah. Or light paths that go past them. Yeah. Okay. All right. What else you got?
Dick Craig from Facebook, he wants to know, can the mass of the Earth change, and wouldn't this slow or speed up our time?
Well, the mass of Earth is changing every day. We're gaining several hundred tons of meteor dust a day.
Oh, really?
Yes. But Charles, aren't we also losing some air to the or isn't?
Yes. A small amount going out. The mass coming in is still more than the mass going out, though, on a given day. So we are growing a little more massive every day.
So the mass going out is we're losing some of our upper layer of our atmosphere.
Yes.
Correct? Okay. So, but 300 tons sounds like a lot, not compared to the mass of the Earth. And I try to run some numbers on this, Charles.
Oh.
And I got something like a gnat flying full speed ahead into the side of an elephant was some huge factor greater than what Earth would feel if it got hit by a comet slamming into its side. And so you don't see elephants concerning themselves with their mass by how many gnats land on its back.
Yeah, but if the elephants became bigger every day from gnats, give it a billion years, that's a little bit bigger.
Yeah, okay. All right, so let's answer that question, Charles. So let's make the Earth a little more massive. So
right.
what?
Well,
now,
Earth
what do you get?
is 6 times 10 to the 21 tons, right?
Okay.
If you add 300 tons a day, that's what, 1 million tons a year? That would still take longer than the age of the universe to double Earth's mass. So we would have to wait a very, very, very long time to see any gravitational effects.
Any meaningful gravitational effects.
Meaningful gravitational effects.
I have time. Okay.
And if Earth's mass go up, then we all start weighing a little bit more.
Yes, right. But there's no effect in our orbit, really, because the way that Newton's law of gravity works, the speed of our orbit around the sun would not change unless, appreciably or measurably, unless we started to approach the mass of the sun. And Earth is less than 1/300,000th the mass of the sun. So that's not going to happen for an even longer time than the age of the universe.
And by the way, what Charles is doing here, we spend many, many years in solving problems, thinking about how the universe works, by recognizing this quantity is large, that one is small. Here we can ignore the small quantity. Or this quantity divides away. And these are tactics we have to gain some sense of how the universe works without worrying about it on such a level of detail that it becomes a distraction. Yeah.
Right. Like, just quickly in my head, I would say your analogy of gnat on an elephant is very close to the actual effect. You can imagine if Mount Everest were hit by a snowball every day, how long would it take before Mount Everest would actually be appreciably more massive or more large, say, than it is now? And the answer is a very, very, very long time.
Yeah.
Right. Okay. What do you got?
Michael Vaca from Facebook, he asks, I'm concerned Snowden is right about strong encryption making alien signals look like background noise. Are there other ways to sense life remotely? I don't know about what Snowden...
Well, so we interviewed Ed Snowden for Star Talk, and we are proud on Star Talk to have brought him to Twitter. And so I had the very first conversation with him on Twitter that he promised he would do on air with us. And so in that conversation with him, we talked about encryption. And Charles, there's an interesting part. I don't know if you caught that episode. So hold encryption aside for the moment. Let's look at a JPEG or MPEG. So what does it do? It takes a signal that otherwise has a lot of information in it, but maybe not so much, and it somehow combines content in a way that reduces the total information a little bit, but retains as much as it can so that you can minimize the size of the signal as you transport it. Okay, so in an image of you right now, there's a large white area background. I can represent that mathematically rather than having to retain all the details of that. And my mathematical representation is more efficient to move through space, through anywhere, than if I represented the whole thing. So there is a hypothesis that a sufficiently intelligent alien will take their signal and JPEG it so effectively and so efficiently, if I can use that JPEG as a verb, that there'll be no discernible information left for someone to reach in and decode it. And so they're perfectly communicating with one another all the time, but we, trying to eavesdrop, will think it's completely noise.
Now, so this is an accidental kind of encoding?
An accidental encoding. So if you want to eavesdrop on civilizations, the most efficient way to send signals is to take whatever is decodable in the signal and re-represent it more efficiently.
Right. Well, that kind of data compression that you describe for JPEGs and so forth, they have an algorithm, right? So you can, if you knew how they compressed it, you could unravel this information.
Well, that's the key, but then you have to send the key on the other side. So we'd have to ask the aliens, please give us a key to your encoding methods so that we can eavesdrop.
Okay, so no one thinks that we're encrypting some stuff. They're encrypting stuff so strongly. Not encrypting, but
compressing.
Yeah, it's not so much encryption. It's compressing a signal so efficiently that the eavesdropper on it will no longer be able to distinguish it just from noise. Because if there's any discernible signal left in it, that meant there's more encryption, or there's more compression that it can still survive.
So then the other question is, are there other ways to sense life remotely? But I don't know that they're mutually exclusive.
Oh, just see if they're polluting their atmosphere on the planet.
Look for planets with other cars?
Yeah. If the exoplanet has aerosols, ozone depletion, smog, that's a guarantee there's no sign of intelligent life.
And if we are able to watch some system for a long period of time, for example, we can watch for periodic behavior, right? Like just the way that decades ago people thought that maybe pulsars, which are dead stars that turn very rapidly, maybe that their regular beating was a sign of intelligent life.
Right.
If we had many such beats coming from, say, a single solar system or something like that, then we might imagine that there were many such things happening. And if there were enough...
In other words, it's not random, and so you've got
finding non-random
if it's not random and it's predictable, then maybe somebody's doing the non-randoming and the predicting on the other end.
Right.
Yeah, we got just a few more seconds for this segment. Do you have a quick one, or do we have to delay it to...
I'll ask a quick one.
Quick one, go.
Linton John Davidson from Facebook asks, how do I get people interested in science?
Oh, that's a quick one.
That's
you lying.
Sorry.
You are lying. You are lying.
You said quick, and what I interpreted as, I could read that very quickly.
Charles, give me your best 8-second answer to that.
Listen to Neil when you get the chance.
I have another quicker one. How's that?
That shows he's a friend. That's right. All right, quick, real quick, go. What's this?
Okay, to it. Andrew, from Facebook, he asks, explain Graham's number.
Have no idea. We'll think about it over the break.
A smiley face.
When Star Talk continues on Cosmic Queries Potpourri Edition. Charles, can you hang on for a bit?
You got it.
We got it. We'll see you in a bit.
Did you know that I sleep great? And it's all thanks to Casper. I'm not talking about the friendly ghost. I'm talking about the mattress. Even though when I sleep, I feel like I'm dead to the world. Did you see what I just did there? Okay, enough of that. Casper is a mattress company that is truly changing the game. They use 2 types of foam in their mattresses: latex foam, which supports, and memory foam, which gives you a bounce. So you get just the right amount of sink, just the right amount of spring. And no pricing games. Like I said, sometimes mattresses can cost you over $1,500, but Casper has a very straightforward pricing plan. $500 for a twin, $750 for a full, $850 for a queen, $950 for a king. And it's completely risk-free. You can try their 100-night home trial, risk-free in your own home for 100 nights. If you do not like it, they will pick it up and refund you everything. You have nothing to lose. Oh, wait, I take that back. Maybe you lose a bad night's sleep, or maybe a backache, or maybe a couple grumpy mornings. Look, I'm going to make it even easier for you. Get $50 towards any mattress purchase when you go to Casper.com/StarTalk and use the code StarTalk. All right, what else do I have to do? Do I have to bring the mattress over, set it up, get in the bed and sleep with you? Oh, you'd like that, wouldn't you? Remember, go to Casper.com/StarTalk and use the code StarTalk.
This is StarTalk.
We're back on Star Talk, Cosmic Queries, Potpourri Edition, which is all the questions that didn't fit in any other category that we've been doing Cosmic Queries on. And so these, I think they drifted in, and I have help back up here, my friend and colleague Charles Liu. Charles, you tweet, don't you?
I do, at Chuck Liu, CHUCKLIU.
You never told me I could call you Chuck, but now your Twitter followers can call you Chuck. I don't know what that means.
I was called Chuck all through high school.
Okay, you just never introduced yourself to me as Chuck. I thought we were friends. That's all I'm saying.
Neil, I'm Chuck. Nice to meet you.
And you are professor of physics and astronomy at CUNY, Staten Island?
That's correct.
And you also run part of the graduate program there, is that right?
Well, I'm part of the graduate program, and I did have a graduate student until recently. She graduated. She's now a professor in the Western United States.
Okay.
So life is good.
Cool. All right, keep that going. So Eugene, thanks for being on Star Talk, and you are the reader. Neither of us have seen these questions.
No.
So just give them to us. Potpourri.
Right. Let's do it. Matt Alley from Facebook /San Antonio asks, trillions of years in the future when the universe is in its final whimpers, how might an advanced civilization be able to hold on to survival by harvesting energy from the last remaining celestial bodies?
Ooh.
Wow. Well,
yes.
They're talking about a future where all the gas that currently coexists with stars has been turned into stars, and the stars, one by one, start to burn out.
Mm-hmm.
And so when you go some trillions of years into the future, they will be the last civilization on the last planetary system around that last star. So Charles, what are your reflections on that?
Well, the questioner may be referring even further into the future when protons themselves start to break down and then black holes themselves dissipate through Hawking radiation 10 to the 100 years from now. In that case, then there's really no way to harness that energy because it's all kind of waste heat, entropy, and so forth. But you could imagine...
Wait, just to be clear, so what we're saying is you can have stars burn down, but there's still other ways to extract energy from phenomenon in the universe. But the universe is actually winding down in every possible measurable way.
Right.
And so when the particles decay to even lighter, smaller particles, then they can't decay into something else. And then you are left with a particle energy wasteland.
But is it possible to have some sort of artificial planet that you live on that...
No. This is the deep part about it. Because anything artificial meant you created a thing that has a metabolism and a source of energy to drive it.
And the energy will be completely gone.
The very fact that you would claim to be alive in that situation, you are producing energy. You have a body temperature above air temperature. You are a machine.
Thank you.
You can... And even when you die, you're a microbial machine with your molecules are still decaying.
There won't be enough dead bodies for this artificial planet to keep eating, is what you're saying.
Charles, how about the dead body energy source?
Well, you could do the best you can, but in the end, once you get to the true heat death of the universe, there's really nothing you can do other than, I don't know, maybe start a new universe.
Aha! There is a solution, and it's to start a new universe.
I didn't invent that solution. You should refer to one of Isaac Asimov's great short stories called The Last Question.
Oh,
I think it's really, really profound and deep. He wrote it very, very well.
Okay. All right. I think I've read that long ago, but I'm going to pick it up again to find out.
Right.
Thanks for that reminder.
So create a new universe.
Create a new universe.
I don't know if it's trillions of years from now that science might exist.
All right.
All right.
What else you got?
I have more. Okay, Jazz, Jazz Gonzalez asks, hypothetically, if someone was to successfully create and open a wormhole to go back to a past time, would that wormhole continue to suck in atoms and the environment around it, eventually imploding and possibly destroying the universe around us?
Yes.
No.
Okay.
I think
Right.
no. Yeah.
Wait. So
Are there a handful of reasons or just like, no?
Well, a wormhole, when you create something like that, it's naturally going to collapse in on itself.
So it's unstable.
Yeah, unless you continue to put tremendous amounts of energy to keeping it open, right?
Okay.
And so it won't spontaneously sort of go out of control and grab as much stuff as possible, sort of sucking everything in.
What would be
itself.
cool, though, is if the wormhole, which gives you access to the past, which does give you access to the past through certain trajectories through it.
Yes.
If you put the entire universe back through the wormhole, you can send the whole universe back to yesterday.
Yeah. Whoa. How about that?
In principle.
Great. What did we just discover? What exactly are you thinking?
Charles, call me later on that one. We get the equations on that.
I think we got a paper to write.
Yeah, okay. All right, what else you have?
Okay.
Wait, just before we went to the break, there was that question, please explain how big a what is? A gram? What was it?
The gram, sorry, it was around here. Oh,
Graham's number.
Explain Graham's number, like graham cracker.
GRAHAM.
Yeah.
Apostrophe S.
I had assumed it was like
Sorry, I've never heard of it.
theorem.
I've never heard of it. Have you?
It's if you take a certain geometric expansion of numbers to try to get to big numbers. You know how like a billion is a big number because it's got 9 zeros after a 1, and a Google's even bigger because it's got 100 zeros.
I read about that in Numbers Magazine.
A Googleplex, which is
so it's one of those big numbers that has a name, is what you're saying.
It's a gigantic number, and it's based on you can construct it using a geometric expansion.
The only big number I knew of was Skew's number, and I didn't know Graham had a number too.
A big Skew's number, which is bigger, you think?
That's 10 to the 10th to the 10th to the 34th power.
Why so weird at the end?
Which dwarfs a Googleplex. Itself dwarfing a Google.
Why is it to the 34th, not 35th?
Because Skew's did it.
Okay.
No, I don't know. I mean, they come up with these numbers. That's what I'm saying, and it surely has some significance in mathematics,
right?
That I cannot glean.
Okay.
At this point,
right now, Graham's number is actually way larger than even Skew's number. I don't know exactly how.
3 times as large.
It's twice as big.
Twice as big.
Right.
Just very big.
If what I have heard is that if you take all the numbers that Graham's number would take to write it out in actual physical form, even if each number,
each numeral
were smaller than an atomic nucleus, there would still not be enough room in the entire observable universe to hold the representation of Graham's number.
It's a very big number.
Thank you, Eugene, for confirming that fact after Charles just explained how big it was.
Well, now I really have a sense. It sounds quite big.
Okay. All right, what else you got?
All right, let's go. All right, from Eddie from Godly, Texas asks, regarding the Fermi paradox, if aliens do exist, which of the possibilities do you think is the most likely scenario?
Charles and I will trade off on this. I would say the most likely scenario, I have 2 most likely scenarios. One of them is that they have actually visited Earth.
Well, do we need to explain to people what the Fermi paradox is to begin with?
You're right.
That's probably a great call.
You're right. I thought Eugene would do that, though. But
no.
Sure. I'm assuming it's the ways aliens might have exist or visited.
No. So if you can run the numbers on this, and if aliens are like humans and live as long as humans do and are ambitious like humans, then they might have a space program, and then they would go colonize a planet.
Yep.
And then that colony would then build its own space program and colonize 2 planets. And then those
I would have colonized 2 planets.
Oh no, so we're 1 planet, we colonize 2 planets. Each of those 2 planets colonize 2 planets, all right? So it's 2 to the nth power, which grows rapidly. It's an exponential. And it turns out you can occupy every single planet in the galaxy in less time than it takes for you to evolve from one species to another. And so under that calculation, if there are intelligent aliens anywhere who had this ability, where are they now? They should be pitching tent right next to us. And Enrico Fermi, a famous Italian physicist, proposed this question. So either there are no aliens out there, or there's some other explanation for why we don't see them. And so I have two explanations. One of them is they came to Earth already and saw humans and concluded there's no sign of intelligent life on Earth and left. Okay, did have one. Then another one is maybe they landed the same day that Comic-Con was happening. And so nobody...
So they're in San Diego.
They're in San Diego. But Charles, do you have a less comical answer to this question? This very serious question.
Well, one of our colleagues, Steve Soder, actually told me this idea.
But Steve Soder co-wrote both Cosmos series in 1980 and the one that I hosted. Go on.
Yeah. Steve said that it's possible that once intelligent civilizations achieve the ability to colonize, they wind up all destroying themselves before they successfully do the colonization. If you can, for example, create a spacecraft that can go some tremendous speed, a 1% the speed of light or something like that, you're too tempted to use it as a weapon against your enemies rather than doing something productive like exploring space.
So I think the argument was even more subtle than that. It was whatever is the gene for expansionism. If I expand to here and you expand to there, I also want to expand to where you went.
Right.
And so you have overlapping borders of expansion, and that has the seeds of its own undoing.
Right. So it creates annihilation before we see them. So we, in that scenario, are doomed to self-destruction at some point when we get sufficiently advanced enough technology to do so.
It's
That's
a very
sort of the depressing,
unidyllic Star Trek is what you're describing.
Yeah.
And I think Eugene's hit the other one that I think of, right, is that aliens are sufficiently benevolent that they hide and disguise whether or not they're there, so that they allow us to develop and become citizens of the universe in a cheerful
That is so beautiful, Charles.
I didn't invent it.
Or we are their computer program and somebody's PhD thesis to create a universe.
We're the dish. Yeah. Absolutely.
How long would it take us, how long do you think before humans could actively colonize some other
You'd have to colonize it on a level where then you become another civilization that needs no reference back to the original. So we speak English in the United States because colonists came from England.
Yeah.
And so England, in a sense, landed on the moon because descendants of their colonies did that.
Right.
All right. So you have to become a self-sufficient thing and not just still on the dole.
But meaning how likely is it that there's civilizations like ours that just also can't colonize? Because
we're too stupid or too ineffective to know how.
But and then there's other ones like that too.
Yeah, I don't see any signs on our horizon that we are that kind of civilization, that we're going to occupy every corner of the galaxy because we're that awesome. I don't see that happening.
All right.
Next question. What do you have?
Okay. Ronald James from on Facebook asks, how fast is the universe expanding from an Earth-centric perspective in light years per Earth year? Also, how fast is the rate of expansion, same units, increasing due to this dark energy junk?
Yeah, Charles, you have those numbers in your head? I don't have them.
The current expansion rate of the universe, astronomers refer to as the Hubble constant, right? Which is 73 kilometers per second per megaparsec. Mm-hmm. And if you do the proper unit calculations, that just basically means that we are expanding at about 1/14 billionth of our own diameter per second.
Oh, okay. So every year we expand 1/14 billionth.
1/14 billionth of our current diameter.
Gotcha.
Okay.
Yeah.
You have that. I did the calculation.
You agree? Yeah, you agree.
Yeah.
Okay.
When you weren't sure, I was like, okay.
By the way, you can imagine growing anything at that rate.
Yeah.
Right? What grows at 1/14th of its size? No, 1/14 billionth of its size per year.
Hatred.
So that's the rate at which the universe is growing.
Okay.
So good way to think about it, Charles. I'll use that again for sure. Yeah.
Okay. Mm-hmm. Ocean McIntyre asks, could neutrinos and their oscillations play a role in detecting, mapping, and understanding dark energy.
Ooh.
Totally. 100%. Yeah. Neil, you want to explain neutrino oscillations to people?
Yeah, so neutrino, they're different species. It's like...
Call. I like the answer of yes. And then I'm like, no, yeah, but I wonder, other than on Star Trek, where you create a net and then you can see the invisible alien, but how else does it work?
So neutrinos are one of the fundamental particles of the universe. Neutrinos don't decay into some other kind of particle, so we consider them fundamental. And
would you have enough to use as energy at the end of the universe?
Yeah, no, because once you decay to the lowest energy neutrino, you're done. So there are 3 different families of neutrinos, and the neutrino oscillations is a fancy word for saying a neutrino moving through space can actually transmogrify into another species of neutrino. So it'd be like I toss you a basketball and you caught a football.
Right.
Right. And that story has an interesting history, because we made a prediction of what rate the sun should be producing neutrinos based on our understanding of how the sun works. And we were not measuring those neutrinos. So either we were completely wrong with our understanding of thermonuclear fusion, or the neutrinos were misbehaving, and that's what we found. We didn't know the neutrino would turn into a different species between being formed in the center of the sun and reaching us here on Earth and our detectors.
And there's no transfer of energy between it changing from a basketball to a football?
Generally, you lose energy. What happens there? You
do change energy.
Yeah. It's an energy state.
The missing neutrino problem was precisely that, because it realized that the detectors that we were trying to use to find the neutrinos from the sun were only sensitive to one kind of neutrino at a certain energy level and not to the other kind.
Right, exactly.
And so right.
In fact, the sun was throwing us a basketball, and we were catching footballs and didn't understand why.
Okay.
Yeah.
And so
we got to take a quick break. Sure. We're going to take a quick break, and we'll be back with Cosmic Queries Potpourri Edition. Stay tuned.
Hey, it's time to talk about Squarespace. I don't even use a script when I talk about Squarespace because I love Squarespace. I built my website with Squarespace, and it was so easy. I'm still impressed with me. Actually, I'm impressed with Squarespace because they made it all possible. Now, you're thinking right now, there's no way I could build my own website, and you're wrong. I'm telling you, Squarespace makes it so simple. First off, they have 24/7 customer support, but it's so easy to build your website that you probably won't even use it. You can build a beautiful website with no coding required. If you know how to drag and drop a file, then you can build your website with Squarespace. Here's how it works. Squarespace provides you with these gorgeous templates, and then you populate them with your own personal information, no matter what it is, whether it's videos or your blog or pictures, what have you. You customize those templates so that your website looks unique and unlike any other website. You want an online store? Well, guess what? They can give you that. Sign up for a year and get a free custom domain name. The wonderful thing is that your website is going to look gorgeous, and it will scale to any device, whether it's a phone, a tablet, or a computer. So I really don't know what you're waiting for. You know you're going to need a website at some point. So here is what I need you to do. Go to squarespace.com and start your free trial today. Go to squarespace.com, enter offer code StarTalk, and get 10% off your first purchase. Squarespace.com, 10% off your first purchase using offer code StarTalk. Just ordered my books. You don't know what the books are? Well, you better get to know them, because Mother's Day is coming up. It's May 8th, and you probably haven't done anything just like me. So I sat down, I was about to read this, and I went, what am I doing? I haven't gotten my mom anything for Mother's Day yet. Let me order my books right now. Books are flowers that are grown at eco-friendly farms on the side of a volcano. No, I'm totally serious. On the side of a volcano, for a reason. The blooms are larger, the colors are more vibrant. It's a better soil and more sun, at a lofty 10,000 feet kind of thing. And I just ordered them for my mom, and I'm very happy because I'm going to do something else. I don't know what yet, but at least I got this out of the way, and you can do that too. You know, your mom knows second-rate flowers. They're the crappy ones that you pick up at some massive online outlet or at some store on the way home or on the side of the road. Look, what you really want is some gorgeous flowers from the Books that says, "Hey, Mom, thanks for all that you do. You're the best mom in the world, and these gorgeous flowers show you that I really care." So what's all this gorgeousness cost? Not much at all. Books prices start at a mere $40. No upcharges, no extra fees. Even delivery is absolutely free when you register with the Books. Listeners to Star Talk save 20% off the bouquet of your choice. Just go to Books.com. That's BOUQS.com. Use the promo code StarTalk. Remember, BOUQS.com, promo code StarTalk. And then have your mother thank me.
This is Star Talk.
We're back, Star Talk. Cosmic Queries Potpourri Edition. I got Eugene Merman reading the questions. And thanks, Eugene, for as always for doing this. And Potpourri is so random. I need help, and I'm bringing in my friend and colleague Charles Liu. Charles, thanks for being here. And at the last 5 minutes of this, we're going to go to the lightning round, where every question has to be a one-sentence soundbite.
Okay.
We'll get through many as we can. So I hope you save some for the lightning round. Okay. So give us the first question. Go.
All right. James Coultus from Twitter asks, what are some of the most exciting astrophysics discoveries we've made in 2015?
Oh, well, the New Horizons flyby of Pluto.
Pluto was rocking the whole year.
Dawn's flyby of Ceres. And on September 14th, 2015, there was a gravitational wave that came through Earth.
So that happened in September. So that was good. Keep going on the list.
Oh.
More?
No, yeah. You gave 3 things. Go on. Anything else?
Gee.
I got one. I think this counts. SpaceX successfully re-landed the first stage of its rocket, which opens up a reusability of rockets for the future. It's a commercial technological achievement, but I think we shouldn't underestimate what potential value that can have in inexpensive spaceflight going forward.
Yeah, Blue Horizons did something like that too, right?
Yeah.
Blue Origin, excuse me.
No, but it didn't go into orbit. I don't think.
That's right.
Yeah. This one orbited, deployed satellites, came back and landed safely.
First stage came down.
First stage, and the rest of it went into orbit. That's correct.
Yes.
But in this other one, I don't think anything went into orbit.
Right. It just went up to the 100-kilometer level.
Yeah, the atmosphere edge. Yeah. So good question there. Okay, keep it coming.
B. Demari asks, can dark matter be 3D matter in another dimension? Maybe it fell into a black hole?
It could have, but the thing is, we know so little about dark matter, it can literally be anything.
That's why we call it dark matter.
Cosmologist Rocky Cobb likes to say that dark matter is a model in search of a theory, which basically means almost like millennia ago when people designed things like epicycles and retrograde motion explanations, that we're almost at that stage. So it could literally be anything. It's not likely to be certain things, but it could be anything.
Okay.
I got to go with Charles on that.
Yeah, me too. We're all 3 of us. Jacob Sauber asks, when the sun becomes a red giant, what will happen to the asteroid belt and surviving planets?
Ooh, nothing. Nothing. Yeah, so the sun becomes a red giant, and it'll make a very beautiful nebula surrounding a very dense core. But the red giant is not going to reach the size of the asteroid belt in the red giant stage. It's not. And so the asteroid belt doesn't know or care that the sun swelled up. It's the same amount of mass centered at the center of the solar system. So now the heat distribution among the family of planets and comets and asteroids will be different. Earth would have been burnt to a cinder. Mercury would have been vaporized deep within. Same with Venus. So, yeah.
Is there a planet we could move to that would be maybe equivalent of what Earth is
Charles,
like
I think we can move to Mars, can't we?
No, I'm afraid not.
Is it too close?
Mars is still too close.
So one of the moons of Jupiter, then?
You might
Perhaps.
do all right in the moons of Jupiter, but there is still a big solar wind, right? Remember that the process of becoming a red giant takes hundreds of millions of years. And so in that process, as it grows, more solar material will slough off.
Yeah.
And if there's too much of that, it will still blow away atmosphere and things like that. But once we get out to Titan or maybe Triton, the solid material should be able to hold together at least for a time.
Right, and we mentioned the moons of Jupiter because Jupiter itself offers no surface on which to land.
Right.
But of course the moons do.
So maybe we go to those moons, and then as we do that, and then we move to the next place. I mean, it's
Right.
not ideal.
But that's 5 billion years from now.
Yeah.
5 billion years of evolution, if we're still needing to be in spaceships to go somewhere solid to live and survive, I think we're in deep trouble evolutionarily.
Yeah.
Meaning you think we'll be energy beings?
That's kind of what he said.
Fly around solving crimes?
That's kind of what he said. We'll be.
I'd appreciate that, sure.
Okay.
Yeah.
All right.
Anybody you think it'll take time? Like I can't do it in the next year or two?
Let's just say it's something to look forward to. I wouldn't change my retirement plans.
Next question.
Okay. Terry Carter asks, is there presently any living thing on Earth that could live on the moon or Mars? Yeah.
Not on the surface. I don't think on the surface, but you could probably hide stuff in the subterranean caverns of Mars. What do you think, Charles?
Yeah, I think, tardigrades have been big in the news lately as far as extremotolerant organisms are concerned. These are little mites that live, for example, in places like your eyelashes, right? They can survive the vacuum of space for a period of time. Certainly, if we go into low Earth orbit and then bring them back down, they have been shown to be able to survive the rigors of space for a while. If you can dig them down into, say, Mars, where there's quite a bit of frozen water, and maybe occasionally that frozen water becomes liquid, those tardigrades could survive. They probably wouldn't like it, but they could survive.
But probably not the moon, we're saying.
Yeah, we don't know enough about the subsurface environment of the moon to really know whether they could survive there. I imagine maybe there are some microorganisms that could, but
let me broaden that and say everything we know about complex organisms tells us we're hosed in
like
either
cats
place.
would not.
Cats,
no chance.
right not.
No cats. We're under the 5-minute warning.
Okay.
And with this, we're now the lightning round. Okay. Charles, it's soundbite answers. We're gonna get as many through. Okay, ready, go.
Okay, Thomas asks, if a W hole entrance exists within an object's sphere of influence, does it affect objects on the other side?
I don't know. Charles, go.
Yes, but we don't know how yet.
Okay. Next.
The teen poet asks, is it possible to use gravity to manipulate the flow and speed of light and therefore outspeed it?
No.
Okay.
I agree with that. You can't beat a light beam anywhere unless you
not even if you're a light beam riding a gravity wave.
No, you can. If you ride, you can't surf a gravity wave to go faster than the gravity waves.
No, the universe can expand faster than the speed of light overall, but anything in the universe in space-time cannot go faster than a beam of light going through that same space-time area.
Yeah, the light wins every time. Okay, next.
Okay, Jeffrey wants to know, do you think we could put small asteroids in an orbit around the sun to use as a midpoint to get to Mars?
In about 60 or 70 years, I think. What do you think, Neil?
I don't see the need to have a midpoint. What you would want are filling stations along the way and do a mid-air or mid-space refueling because you're going to have energy of motion to get you from Earth to Mars, to Mercury. And that energy, you don't want to compromise that energy. You want to stay with it all the way and ride it in.
You want to have moving gas stations.
Moving gas stations, exactly. Filling stations. Or next.
Okay. If you had the equivalent money that we spent for Apollo today, what would your goal be?
Ooh, that would, in today's dollars, it's about $100 billion. And I don't know, Charles, what would you do with $100 billion?
I would try to stabilize the carbon dioxide emissions in our atmosphere.
Charles, that's so responsible of you. I mean, come on.
And then once that was done, would you go to Mars?
100 billion isn't enough to go to Mars with modern technology.
I know what I'll do. Okay,
that's too bad.
Okay, I would try to be more noble than Charles was. I would use the $100 billion to make all 7 billion people on Earth so scientifically literate that any next decision they make will involve going to Mars because they'll know the wisdom of it
and they'll
solve the problem. Next.
Okay. What are some tips you would give to someone studying physics in college?
Take the hardest classes you can. Don't worry about whether it's an A or a B in your grade, because at the end of the day, people will beat a path to your door for accomplishing things that no one else could, because that's what it means to take a hard class. Take an easy class and get an A. You show people your grade, but that's the grade everyone else got. And you're no longer distinguished in the marketplace.
Neil, that is the most eloquent explanation that I've ever heard of that correct phenomenon.
Okay, says the man who knew nothing but straight A's his whole life. But go.
Why do all the planets orbit the sun in the same direction?
Ooh, so there, back in the mid 1700s, this we think that was solved by some great philosophers back then. One of them was it Laplace?
Yes.
Yeah, it's Laplace. So it's called the nebular hypothesis. You have a huge cloud, out of which you will make the solid stuff from collapsed pockets within it. It rotates. Everything in the universe rotates. And as this cloud collapses, it speeds up, pockets form, and therefore everything that forms from that cloud will rotate with the same sense of direction as everything else. And so potent is that understanding that when something is moving in a weird direction relative to it, that tells us it has a different origin and it's interloping through our own solar system. And it's really, really cool. I think that is, Charles, do I get your amen on that?
You're right, unless maybe something in the solar system whacked something else in that solar system.
Yeah, you can get whacked in the solar system.
If a moon hits another moon, something could go differently.
I didn't know you work for the Sopranos. Yeah, okay.
Hey,
yeah, you get whacked. Yeah, for example, is it Neptune? Uranus, its orbit is flipped completely the other way. It doesn't rotate in the same direction as everybody else.
Oh, really?
I think something knocked it on its ear. We got to take a break here. When we come back, I'll have Bill Nye, the science guy, in studio for the part of Star Talk we call How Tweeted Is. Stay tuned.
This is Star Talk.
We're back, Star Talk, and this is the How Tweeted Is part of the show. Bill Nye joining me here.
So good to be here.
Good to have you. And you tweet at Bill Nye.
I do.
Nice, very nice. So I posted a tweet out not that long ago. Just came upon, these are like brain droppings each day. But I know you've thought about this. So here it is. Proud to be Homo sapiens, a curious species with DNA compelling us to explore, even if doing so puts your own life at risk.
Apparently.
Why? People are ready to kill themselves.
Well, the word kill themselves, they're willing to take risks. Because taking risks, well, when you take a risk, there's a chance you'll succeed. At least when I take risks.
It's interesting because that's not how I think of risk. I think when you take a risk, there's a chance of you dying.
Yeah, well, there's
fascinating.
non-zero.
That's a fascinating other way to think about risk.
It is a one-sum game. That which does not kill you, you presume would leave you alive,
right.
And the risk is taken with the chance of enriching yourself. And let me just put it this way, everybody. You're a woman, you're a female. You could go with the accountant there in the cave, in ancient cave days, Og and Augette back there. Or you could take a chance on the guy who's a little wild, who goes over the hill and maybe will invent PayPal and just get crazy rich. And so if you put your cards in with that guy, put your lot in with that guy, there's a chance that you will also succeed.
What are you saying about accountants?
I'm saying the accountant's a steady guy, but he may not strike it rich. So there's some value in the striking rich scenario.
Okay, but if that were the case, there'd be no accountants.
Oh, no, because everybody's got to pass his gene. The guy who goes over the hill may get killed.
Oh.
There's lions and tigers and bears and parasites.
That'd be 3 different continents, actually.
All that aside, I was trying to cover them all. There are penguins,
That's you just added a continent, right?
And then there's some New World monkeys that are trouble.
No, the point is,
plus in Australia, everything's venomous. So
okay,
yeah.
So but the guy that goes over the hill attracts the female, then the male that stays in the cave doesn't reproduce. Is that right?
No, well, it depends on what choice certain females make. I'm saying there's value in the guy taking risk.
Okay.
Not that accountants don't take risk, but comedy is based on stereotypes, or expectations, which are based on stereotypes. So my feeling is that the ancient cave accountants were more conservative than the ancient cave over the hill, let's go for it explorers.
Okay, and so the over the hill, let's go for it explorers who never came back the accountant had all the women. Okay, that's how the male accountant had all the women. Okay.
That's why I became an engineer.
Okay.
It's a compromise.
You've been listening to How Tweet It Is. Join the conversation at Star Talk Radio on Twitter. I'm Neil deGrasse Tyson. Bill, thanks always for being on the show.
Thank you, Neil. Let's keep looking up.
As always, let's change the world.
Yeah!